Hi, thanks for joining us today. My name is Joe Young. I'm a PM in the SQL Server product group, and today we're going to talk about a solution in SQL Server 2012 that we've introduced that will help you solve some of your application compatibility testing and general application testing problems. Think about situations where you had to figure out, how do I get a realistic workload test before I roll something into production or before I make a major change? And that's really one of our core goals we're trying to address with a feature called Distributed Replay, brand new in SQL Server 2012. So what is Distributed Replay? Think of it as Profiler of earlier versions, but just the replay portion of that. So it has the ability to replay events that captured from a previous workload, but unlike Profiler, this is a one-to-many type of replay scenario. And what I mean by that is it has the ability to replay using multiple load generation engines as opposed to Profiler, which is only a single client, single-threaded engine. And some of the enhancements we've made under the hood allows us to drive much higher workloads and much higher fidelity of these workloads so that you can do both functional and performance tests. For now, this current version, we are focused more on the functional testing aspects of that, and I'll show you some of the examples of what we can do with it. Now, so why do we enhance a replay tool, although we've already got Profiler, which does some of that stuff? Well, for starters, a lot of customers tell us that they want to be able to stress the machines or want to be able to run playbacks at a much higher rate or run much larger playback files, which makes it fairly difficult in Profiler, given that if you run into several gigabytes of a trace file, it becomes very painful, where it takes a long time to complete the replay. In some cases, it could run over several days. So by using Distributed Replay, you can now replay the same large files using multiple low-cost clients or even virtual machines and be able to handle these very large files. We also deal with some of the limitations that SQL Profiler had in the past and enhance some capabilities, better data type supports, better support for handling cursors, different types of connections, connection pooling, and so forth. And more importantly, this actually lays the groundwork for some important work we're trying to do moving forward in SQL Server to make lives easier for developers and DBAs who want to get a better feel for their application, a better way to test their applications on SQL Server before either making major changes or before upgrading to the next version. So the basic underlying concept for Distributed Replay, or DReplay, is you have your current production server, if you look at your screen on the left side, and you would capture a trace just like you would today using Profiler, and this trace file would be transferred to your test environment. Obviously, you don't want to run that in your production. And this trace file will be used to replay against the exact same configuration as you had in the capture environment. The reason for that is you want to capture a baseline to understand its behavior when you're running in a replay type environment as opposed to the actual production or QA environment. So once that replay is done, you would take the exact same trace file and replay that against whatever system change that you've made on the new test server or test system. So it could be some configuration changes, it could be a completely new database version, it could be a service pack addition. Doesn't really matter. Basically, you've made some change and you want to see how that same workload would behave under new circumstances. So once you're done with that, you will take the reports, basically the output from these two playbacks, and compare them, and you'll get a feel for what happened differently between the original systems and what happened after the change has been made. So that's the basic underlying concept. Now, how does that play out in Distributed Replay? So as you can see, on the far left, the user still has the same trace file, and it has what we call a controller, whereby your original trace file is initially managed by the controller, and you can specify specific options and tell the controller how you want to break things out and how you want to prepare the trace files for replay. And you can also specify however many clients you want to go run the test against. We've tested up to 32 clients, if I remember correctly, and you can certainly go beyond that, but I can't imagine anybody having a workload that requires more than even 8 or 12 clients. So, and we'll show you some numbers later of what we got from these tests. Now, the first step is you want to pre-process your trace files that you originally have, and I'll explain later a couple of things you can do in the pre-processing stage. As part of the pre-process, we will generate a number of intermediate files which gets distributed for replay to all the clients that you select. So you could select one or n number of clients, and we will break that out and send all of these intermediate files to each one of these clients so that they will have their own workloads to use and play back against your target SQL Server. Now, each one of these clients independently or working in unison will send batch requests just like an actual workload to the SQL Server, and depending on what kind of options you select, it may complete that right around the same time, or it may run that even faster than the amount of time you took to capture the original workload. And we'll talk about the details a little later in the presentation. A couple of important concepts we want to introduce at this point. The two time intervals, one of them is connect time, and that basically defines the period between the trace start, when you hit start trace, and a user actually establishes a connection. So you may actually have situations where you start a trace and user A logs in after 10 seconds, or user B logs in after 20 seconds, and X number of users come on later after 20 minutes, an hour, and so forth. So we keep track of connect time for different types of stress testings that we'll see later in the presentation. Now, think time is the time between two different events. So within the same connection, you may be executing multiple transactions, and that will result in multiple batches going to SQL Server. And we also keep track of the time between each one of these events, so we know what's going on and how much time is actually busy and how much time is actually idle waiting for something to happen. For example, the user may run a query and gets the results, stares at the results for a little while, and then goes back and follows up with the next command. So we keep track of that time also. You'll see the relevance in this in the next slide. As mentioned earlier, as part of the pre-process, we can do a few things to influence how the replay will happen. The first of all is we want to make sure we sort the events correctly and keep them in the right order. Those of you who work a lot with Profiler in the past, you know there are some situations where the order may not be assured after you've captured it. And in this case, with DReplay, we make sure you have the right order of the event sequence, and that's part of what happens in the pre-process. We also remove any of the columns and events that are not needed for replay in case you've captured stuff in addition to what we need for replay for whatever purpose, maybe for perf tuning, or you want to do some auditing at the same time. A lot of companies do these kinds of captures on a regular basis, so it's a superset of what we need. So we trim that stuff away so that to reduce the amount of load we put on the network. We then generate the intermediate file, which is what the actual replay clients will use to run the replay loads against the SQL Server. The whole idea is once we pull this together, the intermediate file is now the final version, and we can then replay that using different options, which DReplay understands. During the replay option, the user can specify and decide how many clients to use, as mentioned earlier, but you can also tell DReplay how you want the actual replay batches to execute, whether you want it to run and behave the exact same way as captured, meaning it will follow the sequence of events, the timing exactly the way as it was captured, or maybe you want to run it a little faster, you want to remove some of the time that you know is not relevant. Connect time, for instance, if you're running you capture it from a QA environment, you don't really care too much about the connect time because all of those tasks are submitted manually anyway. Whereas if you're capturing off a production server, you might care about connect time because different things might happen and you want to see what happens during different periods of the day or during the period that you captured. So two different modes that we allow you to have: synchronization and stress modes. And under synchronizations, we basically have each one of these clients, assuming you have more than one, would talk to each other and make sure that we can coordinate and get the events in the right order to ensure that it comes in the way that you would expect it to in a real workload. Or we can stress it where each client has minimal guarantees on the ordering, but they are independently able to submit the workloads and target your SQL Server and basically work it as hard as you want. So This table here will walk you through what the different modes are and what actually happens in each mode that you select. The first one, synchronization mode, as briefly mentioned earlier, we make sure that we order the events correctly based on the SPIDs coming through, and we make sure we synchronize the timing also. So if it took the user 20 minutes after you started the trace to connect and then start submitting workloads, we will wait for that before running these events. If you have only 5 users and the wait times in between, we will honor that also. We also make sure that if there's gaps in between transactions, or basically gaps between events, we also maintain that just to make sure that the behavior is almost exactly like what happened when you captured the original workload. So that's synchronization. And there is traffic going back and forth between the clients and the controller to make sure that they are submitting these requests in the right order and based on the right timing. For the most parts, this is usually run for high fidelity replay, where you want to do functional tests and you want to also observe system level behavior or external behavior. For instance, you may have monitors that stare at directories, seeing when file drops and see how those things behave and so forth. That way you're guaranteed that the behavior is the same as when you captured. Stress mode, on the other hand, has 2 separate subcategories where we would provide granularity at either the SPID level, the process ID level, or at the connection level. And within them, you can also alter behavior of how the replay actually takes place. For instance, you can change the connect time between 0 to 100% of the scale. So if the original connect time for user Bob is 10 seconds, you can change that to perhaps 50%, which means it will only consume 5 seconds of the connect time instead of the original 10. So you can alter that for the think time also. You can also choose to use connection pooling or not, and that will also affect the behavior of your SQL Server, given that your resource usage will be different, and there are efficiencies to be gained by that, and perhaps you want to test without to see what happens. Now, if you're running under stress mode with SPID level granularity, for the most part, you'll be looking at performance runs to see if you can hit the SQL Server hard enough and see what happens. Now, there are some workloads that do not play very well to this, particularly those that have high dependencies on previous transactions or previous users. So there are some things you want to be watchful for, and you want to also be careful whether or not you have dependency at the transaction level or at the SPID level. So knowing what that is will tell you whether you can choose granularity at SPID or at the connection level. For the most parts, running performance runs and moderate level of stress runs, you would go by SPID granularity. And if you really want to stress the system out and beat it up as hard as you can, then you probably go by connection granularity. The way that works out is, if you look at the multiple diagrams we have here, starting from the left, if we send in synchronization mode, we will make sure we honor each one of these times. And if the original transaction took longer than the original capture or took shorter, we will compensate for that also using this buffer time that we have in think time. So if we start from the left, the original think time was 5 seconds, but let's say we replay the original workload from 2005, we replay against 2012, and we run a lot faster in that environment. So instead of taking 5 seconds to run, it only took 3 seconds to complete that event. So now we have 7 seconds in between the first and second event. And if you're in synchronization mode, we make sure that we wait that 7 seconds so that the start time for the next event will be the same as when you originally captured. And the rest of the illustration shows you the same thing. If the event took longer to run, we will then eat into whatever think time buffer is available before the next sequence starts. So that's how we ensure that the sequence of events are correctly synchronized and you don't have things potentially running out of sequence. Now in stress mode, under SPID granularity, this is a slightly different scale where we can alter the connect time and we can alter the think time based on whatever custom setting that you want. And as the diagram illustrates, the initial connect time could be 5 seconds, but we choose that, you know what, it doesn't matter. We capture this off a QA system, and let's go ahead and run it through. We don't want to wait, just because it took me 5 minutes to run all the test harnesses. Let's go ahead and get them all fired up quickly. And by setting it down to 10%, it will only wait for 0.5 seconds to connect before starting the first event. We can do the same thing with think time. In this case, I've set it down to 50%, and you can see between event 1, connection ID 51, and the second event, which is a log out, instead of waiting the original 8 seconds, I would actually wait 4 seconds, which is that 50% setting, and I'll go ahead and fire off the second event already. And then the subsequent connection will be able to start and run through whatever events that it had generated earlier. So as you can see, we do maintain SPID level granularities, and we will make sure that they are ordered correctly according to SPID, one after the other. So if your connections have multiple SPIDs, for whatever reasons, it runs multiple jobs, we will make sure we track that and we'll serialize that for you. Now, we can do it also at the connection level granularity, meaning we only watch at the connections, and each one of these SPIDs are independent. So in this case, we could have multiple users here with different users with different connections, and we identify them by the SPIDs 51, 52, and they're from different connections. In this case, each one of them will also honor whatever connect time scale and think time scale that we have set. So in this case, in the first user, it had connect time of 5 seconds. We set it down to 10%, so now it's down to 0.5 seconds. Whereas the second connection, using ID 52, the connect time was 18 seconds, but instead of waiting for all of that to complete and waiting for the first one to complete before running it, we actually just wait the 10%, which is 1.8 seconds, and then we go ahead and fire off the event for the second connection already. So as you can see, in this case, if you have lots of concurrent users and you want to be able to stress the system to see what happens if they all came in roughly around the same time, instead of following the correct order that originally came in, you can change these settings and use stress mode using connection granularity, and you can see how now, instead of waiting serially, these things now occur close to parallel, or whatever configuration you set it to be. Some of the other things that we've done in DReplay that you couldn't do in earlier versions in Profiler, we added support for new data types in SQL Server, SQL variant, money and small money. We've also improved the health monitor to track deadlocks. It is possible to deadlock even in a replay environment, and this is not a database deadlock. This is basically a replay deadlock where it's waiting for events and waiting for the completion of the event in SQL Server, whereas at the same time, SQL Server is waiting for the second event to come through. So in the nature of the replay actually could generate a deadlock. And we have the capability to detect that also. And you have the option of killing the transactions or terminating one of the SPIDs within SQL Server. So the options are available for you, but we provide you the capability to detect that if it happens within the replay environment. Other interesting features that we also add is if you have a situation where you capture the database under different context, or perhaps you have transactions coming through that expects a certain default database, or you have different DB-IDs mapping to your production environment versus your test environment, we have the ability to detect that by looking at the database column within your capture trace file. And if we find a mismatch between your current connection in DReplay during the playback environment and what is expected as per the trace file column, we can actually issue a use database command to set you back on the right database. So if you look at your previous version in Profiler, that would actually generate an error, and your transactions will actually not play back correctly because it's hitting the wrong databases. Now, we also have more details in terms of what results that we capture, and you can certainly configure that to be more granular or less. We capture success event failures. We define that more explicitly, what it means to be an internal error and external and so forth. We also have a number of rows that come back, so you can do comparisons to see if select foo star from foo generated the same number of rows in the current as the previous one. All of that stuff is tracked, and you can use that in comparing your results. Quick note on the versions that are supported, the input trace files that you can capture and the targets that you have. I'm not going to walk you through each one of them, but just bear in mind, we only support the current mainstream supported releases, and the trace files that you capture from these versions can only play back on the same or a newer target version. We do not target earlier versions, for instance 2000, just because some of the underlying infrastructure that we need does not exist in the earlier versions. Now, I mentioned a little bit about performance and scale, so I'll walk you through some of the data we have from internal testing we did with a number of early adopters, both some of the Microsoft applications and also third parties, customers, and ISVs that come to our labs and run dReplay testing. For the most parts, the average workload replays, we'd be using 1 or 2 clients, and the performance is comparable to Profiler. Where we really see gains are the ones that are really large trace files or really complex loads, and we can see anywhere from 3x to 10x, I mean, literally an order of magnitude difference in terms of how quickly we can run through these playbacks. And we're talking about using really very small machines, workstation class machines, and using a bunch of these things. In some cases, we use virtual machines within the same server, and these things can generate a significant amount of stress against the database. In a couple of the TAP customers that we've brought into the labs, one of the largest trace files we replayed was 100 gigabytes. You couldn't possibly replay that in Profiler or earlier versions. And if you look at the graph on the right, the scale factor as we increase the number of clients and we map that to the batch requests per second, it's almost linear. So each time you add additional clients to that, we can actually run through these batches even faster. Using just 4 clients, we can push SQL Server up to about over 3,000 batch requests per second. That's a very busy SQL Server. And we can actually push that significantly higher, but we figured, 3,000 batches per second is more than what most people will generate. Certainly, if you have more clients, it can go a lot higher than that. So what else do we do with that? One of the key goals for providing dReplay is to really improve application compatibility testing. This is really about functional testing rather than performance, and we have the ability to detect things that a wonderful tool, Upgrade Advisor, great as it is, things that it will not detect. For example, if you have ad hoc SQL, embedded SQL within your application, you can capture that in a trace file and run that. And bear in mind that some of these SQL statements will behave differently between compile time and runtime just because newer versions, perhaps there have been improvements in the query processor and some of these queries run faster, or perhaps we have changes in how we manage statistics or gather them, and it will also affect query behavior. So things like that you want to be aware of, and those things are very hard to detect if you use a static analysis tool like Upgrade Advisor. In some cases, it's not possible to detect. For instance, if you have dependencies on external objects or CLR objects, and security settings have changed in the new versions, then Upgrade Advisor will never be able to detect that. Whereas when you run a playback type testing for application compatibility using dReplay, we can capture that and run these workloads as though it were actually a production load, and you will be able to detect any of those issues. Certainly, we do not say that every single application has to go through this, as it takes a little bit of effort to get set up and running, but we do encourage that if you care a lot about the application, if it's business critical or mission critical, the sniff test I would go through is if this application rolled out in a new version, let's say SQL Server 2012, and it went down for 10 minutes, how quickly does your phone start ringing, or will people get really mad at you? If you are not sure if the answer is yes, then you probably want to go through these kinds of detailed testing. And how does that work? Well, it's exactly the same way as dReplay. You want to capture the trace workload from your original version. You want to move that trace file and test that against the exact same original version, same configuration, but in a test environment. And then you use the same trace file and test that against your upgraded database. That's really the only difference here, and this is one of the primary uses that we see for dReplay. And after that, you have comparison reports that tell you how it behaved in your previous version of SQL Server and how it will behave in, say, SQL Server 2012. We do have a version of the Upgrade Assistant tool available out there, which originally used Profiler for capture and replay. Now it uses the same profile for capture, but it uses dReplay to replay the files. So those of you who've actually used this in the past, you'll be pleased to know that some of the challenges you've had in the past with very large trace files and some practical limits, don't go beyond a certain number of gigs, most of that goes away. So now you can actually run significantly larger traces as you want to test your application for compatibility issues before upgrading to SQL Server 2012. We've also made the reporting capability significantly more advanced and improved the user interface also to make it a lot friendlier. So you have the ability to go in there and select and figure out which clients are available and which ones that you want to go ahead and execute instead of just using the same single client that you have in the previous versions. So those of you who've used Upgrade Assistant in the past for 2005 and 2008, you'd be pleased to know that it is now powered by Distributed Replay, and all of the benefits that we talked about earlier with multiple clients, the scale, the performance, all of that now enables Upgrade Assistant to run a lot better with much higher fidelity. So and there are links at the end of the presentation that you can go download the tools from, and places where you can go to and ask questions and look for help. So in short, upgrade really isn't a daunting task, even if you're looking at a major upgrade from previous versions 05 or 08. We provide these tools to make your life easier so you can do better testing up front, make your upgrades more predictable. And there's a ton of resources out there with best practices and guidance to help you in your process. Of course, talk to us via Microsoft Connect and send us feedback on what you like and what you don't so that we can further improve on our products. Thank you.